Hey there, Algebra 2 students. Mr. Weber here. You made it through yesterday's lesson. Wasn't that a lot? I know it was, but the good news is today and tomorrow we're just going to practice more with the unit circle, with all the information that we explained to you yesterday. So I tried yesterday to go through that lesson and go through in a lot of detail so that you understood why each value was what it was. Today we're going to focus on, okay, we got to know this. So let's think of some tips and tricks that will help us remember what these values are, so we don't have to spend 30 minutes writing out that unit circle every single time. So the good news is if you have that unit circle filled out, all of your answers for the most part are going to be there on that circle at some point. You just got to figure out what angle are they looking at, and what trig function do they want, sine or cosine, or what value, x or y, do they want. So once you have that information, you have all the answers. So the hard part is getting that information out. So that's why we're going to try to encourage you to practice doing this from memory as much as you can, so that you can get to a point where you can just whip out a unit circle and fill out most of it in 3-4 minutes. If it's taking you 30 minutes, then it's not worth it. Okay, and we don't want you having to grab a calculator. We want you to be able to do this quick and easy. So that's why you're going to have to practice, 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 and there's no way of getting it without just practicing it. Okay, so here is the filled in unit circle that we went through yesterday. All right, so I hope that you have this on your notes from yesterday or have this somewhere, and this should be like your go-to unit circle. But what I'm going to ask you to do is look at it just for a second, try to absorb as much information as you can, and then pull it out a blank unit circle. Today I'm going to focus on just the angles, so just the degrees and the radians. Tomorrow's lesson will focus on those points on the outside. And I want you to try to fill it out as much as you can. All right, so go ahead, pause the recording, fill out as much as you can. I hope you're doing it in pencil, and then I'll show you some tips and tricks for filling this out. Okay, so we want to fill this out. We're going to start with the easy part. We're going to start with degrees. All right, I'm a big fan of chunking information. So there are 16 different angles on this circle. If you try to remember 16 different degrees and 16 different radians, your head's going to explode. Okay, you don't want to do that. You want to chunk the information so that you can remember it in an easier way. All right, so in degrees, I want you to remember three numbers: 90, 45, 30. And what that stands for is the steps that we're going to take around this circle. And when I say steps, I mean we're going to start at 0, because we know where 0 degrees is. That's just our initial side on the positive x-axis. And we're going to start by just adding 90 degrees each time. So if I'm at 0 and I add 90 degrees, where am I going to be? Directly up. If I add 90 degrees from 90, 90 plus 90 is 180. Now I'm on the left side. If I add 90 to 180, that gives me 270. Now I'm beneath. 270 plus 90 is 360, and I've gone all the way around the circle. Okay? 90, 45, 30. All right, so the next step is 45 degrees. So 45 is easy because it's directly halfway between 0 and 90. So look at what you just did. Just look for the line that's directly in the middle of that. All right, so 0 plus 45 is 45. So if you look at all of these quadrants, there's 3 lines. You're looking for the middle value in all of them. All right, 45 plus 45 is 90. It's already there. 90 plus 45 is 135. 135 plus 45 is 180. It's already there. 180 plus 45 is 225. It's already there. 225 plus 45 is 270. 270 plus 45 is 315. 315 plus 45 is 360, and it's already there. Okay, so we have most of this circle already filled out just in those 2 steps, 90 and 45. The next step we're going to take is steps of 30. And when I say steps of 30, we're starting at 0 and we're just going to add 30 each time. Okay, so 0 plus 30 is 30. 30 plus 30 is 60. 60 plus 30 is 90. It's already there, so I skip it. 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. It's already there, so I skip it. 180 plus 30 is 210. 210 plus 30 is 240. 240 plus 30 is 270. It's already there, so I skip it. 270 plus 30 is 300. 300 plus 30 is 330. And then we add 30 and we're back. So we went around the circle basically 3 different times, taking a different step each time, and we filled the whole thing out. 3 numbers, 90, 45, 30. That's in terms of degrees. Most students are okay with degrees. That's the easier of the 2 to figure out. The harder one is the radians. All right, so again, we're going to chunk it. So we're going to start by thinking about what do we know about radians? Well, we're going to start at 0. That's easy. And instead of going around 360 degrees in terms of radians, you're going to go around 2 pi radians. So we know that part on the far right. Okay, now, if we only go halfway around the circle, so if 2 pi is all the way around the circle, halfway around the circle would be only 1 pi. That's easy. All right, now is when the part you're going to have to remember some stuff. Here we go. First thing I want you to remember is most everything in radians is a fraction. So watch, one move, boom, everything's a fraction. All right, so don't think, just fraction, 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 fraction. All right, the only things that are not fractions are the 0, the 2 pi, and the single pi. And they're all on the x-axis. So do those first, and then everything else is a fraction. Okay? Now, next thing I want you to remember. 2, 3, 4, 6. What happened to 5? 5's just not there. Okay? 2, 3, 4, 6. And here's what I want you to do. You hopefully know that the 90-degree angle, so if we start at 0, half the circle is pi. Half of that, so a quarter of the circle, 90 degrees, is going to be pi divided by 2. So the denominator at that top point at 90 degrees is 2. Now watch what happens. All right, 2, 3, 4, 6. Did you ever notice that these two angles, these two denominators were the same? And these two denominators were the same? And these two denominators were the same. 2, 3, 4, 6. That's all you got to remember. Start at the pole, start at the top, and work your way down. 2, 3, 4, 6. Okay? Then flip it exactly over the x-axis. So start at 270 degrees. Look at your denominators. Guess what they are? 2, 3, 4, 6. The exact same thing happens. So 3s, 4s, 6s. Okay, so the numbers in the middle are always a denominator of 4. 2's at the poles, the vertical poles. Okay, and it goes in order. 2, 3, 4, 6. Okay, let me grab my eraser real quick and erase these lines. So we can move on. All right, so now we got our denominators down, and all we got to do is figure out the top. So again, there's no simple way of doing this other than just little things that I've learned to kind of remember what's going on. And here's the phrase I want you to think about. And it's going to sound silly, but it'll work every single time. Okay, here we go. Pi, one more, one less, all together. Mr. Weber, that's crazy. I know it's crazy, but trust me, this will give you every single thing on this circle. Pi, one more, one less, all together. What does that even mean? All right, let's start with pi. We're always going to start in our first quadrant, and that's typical. Positive, positive. All right, so there's pi, and guess what? Look at your numerators. Pi, 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 pi. Everything is pi. That makes it easy, right? All right, next, we're going to slide from the first quadrant down to the third quadrant. This is just the order that my brain goes through this, and this is how I get it right every single time. All right, pi, one more, one less, all together. So we started with pi, and we got all of the first quadrant. Okay, now we're going to move to the third quadrant, and we're going to think one more. What does that mean? Well, look at this first fraction. The denominator is 6. What is the numerator? It's one more than the denominator. If the denominator is 6, the numerator is 7 pi. If the denominator is 4, guess what the numerator is? 5 pi over 4. If the denominator is 3, guess what the numerator is? 4 pi over 3. Everything in the third quadrant has a numerator that's just one value larger than the denominator. So we already have the denominator, so it's right there for us. No thinking involved. 3 pi over 2. All right, so pi, one more. We've gotten half the circle already done in terms of radians. All right, next one less. All right, so we're going to move up to the second quadrant. And again, this is just the way that my brain thinks through this. All right, pi, one more, one less. So if the third quadrant had the numerator being one more than the denominator, guess what one less means? It means that the numerators in this second quadrant are always going to be one less than what the denominator is. All right, so here we have a denominator of 6. Guess what the numerator is? 5 pi. Denominator 4, guess what the numerator is? 3 pi. Denominator of 3, guess what the numerator is? 2 pi. And there you go. Pi, one more, one less. One last one all together. Are you ready for this? This one's crazy. When I saw this, my mind like literally exploded. All right, so here we go. All together goes to the fourth quadrant. Okay, so here's what I want you to do. I want you to take this, look at the 120-degree angle, which in terms of radian is 2 pi. And look at the numbers above that. 2 over 3. One more, one less, all together. All together means we're going to add. If I take 2 plus 3, what is that? That's 5, right? All right, now look at this line. You see how this line goes through the origin? Follow this gray line all the way down to the angle that's exactly opposite. And guess what that numerator is? 5 pi. 2 plus 3 is 5. Oh my goodness. Does that work all the way around? Yeah, it does. What's 3 plus 4? 7 pi. What? What's 5 plus 6? 11 pi. Oh my goodness, Mr. Weber, why didn't you show us this yesterday? It would have made everything so much easier. Yeah, I know, but I wanted you to know yesterday why things were what they were based in math. Today we're just going to remember it, okay? And this is just a cool thing about the unit circle. It just works out this way. And another way to think about it is look at the first and third quadrant too. So this pi, we can think about this as 1 pi over 3 and 1 pi over 4 and 1 pi over 6. All right, and guess what? I think this is so cool. If I take 1 and 3, one plus 3 is what? 4. Trace that down. Oh my gosh, it's a 4. 1 plus 4 is 5. Trace that down. Oh my gosh, it's a 5. 1 plus 6 is 7. Trace that back. Oh my gosh, it's a 7. All right, and it just works that way. All right, pi, one more, one less, all together. All right, that's my little shortcut to remembering all the degrees and all the radians. All right, now again, what I want you to do is to practice, 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 practice. So what I would encourage you to do is to pause the recording, grab a blank unit circle, and try focusing just on those two things that we just talked about. Try to fill out as much as you can on your own. Check it with that one perfect official unit circle that we filled out together. All right, because you don't want to practice mistakes. All right, so you always want to check every single angle and make sure you're doing it right, because you don't want to practice a mistake. You want to learn it right and then practice it the right way. All right, so you have your official unit circle, you're practicing with filling it out on your own, and then you're comparing that to that original one. Are we okay? All right, hopefully we're feeling better. Those angles are still a doozy, but that's for tomorrow, okay? One day at a time. All right, so we're just going to use this to answer some questions, and I have nothing new today other than show you that shortcut and then to help you practice your homework. So I have like 5 problems. I figured I'd help you do your homework. How cool is that? Yeah, I know, I'm an amazing teacher. But here we go. Oh, the last thing I want you to remember is that the way that all of these ordered pair goes is cosine, sine. So remember, cosine is the x value, sine is the y value. It is alphabetical. X comes before y, C comes before S. So if I want to find the x value of any value on the unit circle, all I have to do is to find the cosine of that angle it makes with the x-axis. Okay, same thing with sine. If I want to find the y value, I just find the sine of the angle it makes with the x-axis. Okay, here we go. Are you ready? All right, so here's our official. We can go back now to the official unit circle that we did yesterday, so we know we're looking at right values. Number one, negative 150. All right, cosine of negative 150. All right, so you can see today's lesson is going to be a little bit more tricky. Yesterday, all the angles were just what I like to say, like straight up on the unit circle. So these angles today might be coterminal angles. So you're going to see why we taught you how to deal with coterminal angles last week. All right, so negative 150 is not on our circle. So there's a couple different ways you can do it. You can find positive 150. All right, positive 150 would be right here, meaning this angle would look like this. All right, but it's not looking like that because we don't want positive 150, we want negative 150. So what you could do is just look for the angle that is exactly the same but reflected on the x-axis. So instead of going up by that angle, it's going to move down at that angle. So it's going to be something like this. All right, so we're looking at that angle 210. All right, so you could do that. I don't encourage students to always do it that way because sometimes they just forget to flip it and they give me the wrong angle. I don't want you to give me the wrong angle. So, we're looking for this angle here. We know that it's negative 150. What we got to find is what is the positive coterminal angle that's going to be on our circle. And we're guessing it's 210 based on just the logic of flipping that angle. All right, but to find it out for sure, just add one full rotation. That's how we dealt with coterminal angles last week. So we're in degrees, so a full rotation is 360. Negative 150 plus 360 is, boom, 210. And we're right. All right, so there's the angle that we're looking at. What are we trying to find? Cosine. What is cosine? That's the x value. Our answer is negative square root of 3 over 2. Boom. Oh, mistake. Sorry, I don't know what happened there. All right, so it should be negative square root of 3 over 2. My apologies for that. Okay, are we good? Are we good? Are we good? Are we good? All right, I hope so. Let's try number 4. I'm going to bounce around because I want to show you some degrees, some radians, some positives, and negatives. So here we have radian, 7 pi over 4, and it's negative. So there's more than one way of doing this. You could find positive 7 pi over 4, which is down here. All right, so we're trying to find this angle here. We're moving around in the negative direction, 7 pi over 4. That's almost 2 pi, but it's not entirely. What we're trying to find is what that little positive angle is. And the easiest way to do it, I think, is just to add one full rotation. We're in radians, so what is one full rotation? One full rotation is 2 pi. But we can't add 7 pi over 4 and 2 pi because one's a fraction and one's not. So let's convert 2 pi into a number with a denominator of 4. All right, so multiply top and bottom by 4. We get 8 pi over 4. 8 pi over 4 is still 2 pi. 8 divided by 4 is 2. We're all good. Now that we have the same denominator, we can go ahead and just add these together. Negative 7 plus 8. We get positive pi over 4. All right, so here's the angle that we're looking at, positive pi over 4. We're looking for sine. Sine refers to x or y. Think about it. It's y. So what's the y value? Square root of 2 over 2. All we're doing is we're finding the angle, and then we're figuring out which value are they asking us about, the x value or the y value, and we're copying it over. There's no really algebra that we're doing. There's no like solving or any of that. All of that was last week to help you set up and understand why the unit circle was what it was. We did a little bit of that yesterday, one time together. But once we have this unit circle, all the answers are right there for us. We just got to figure out what is the angle and what is the trig function that they're asking us about, cosine or sine. That'll tell us to look at either the x value or the y value of that particular point. All right, let's do another one. Cosine of 660. I like this one because it's larger than one full rotation. All right, so Again, this is going to be a coterminal angle. We got to figure out where this is going to land on the unit circle. So because it's too big, we're just going to subtract one full rotation. All right, so 660 minus one full rotation is, man, I forgot. I got these animations all messed up. So if I subtract 360 from 660, I get 300. So there's my angle. So this is spun around more than one time. It's a cosine, so I'm looking at the x value, so the answer's got to be 1/2. Okay, you can see in my drawing of the angle, I showed it rotating around more than one time. It's going to land on 300 because we're looking at cosine, we're looking at the x value. Okay. All right, last one, 12, easiest one. 5 pi over 6 is the easiest one because it's straight up on the unit circle. Where's 5 pi over 6? Find it. Yeah, it's right there. Okay, so there's 5 pi over 6. Now we got to find out, what are we looking for, sine or cosine? We're looking for cosine, right? That's the x value. What's the x value? Negative square root of 3 over 2. Man, Weber, what are you doing? All right, I'll give you guys a little secret is I did all these unit circles wrong, and I had to fix them. And I was up really late last night doing it and fixing it, and I thought I got them all, but I missed some. Yeah, we all make mistakes. Okay, so the answer should be negative square root of 3 over 2. Are we good? All right. Bam. Bam. All right, last one. This is number 18, and I made it the text a little bigger so you guys could see it. So 17, 18, 19 are different types of problems, and it's worded in a way, and most students get this wrong, not because they don't understand what the answer is, but they don't understand the way the question's worded, what it is they're asking for. Okay, so keep that in mind. If you get this wrong, I can guarantee you it's not because you don't know what you're doing, it's just because you don't really understand what they're asking you to do. Okay, so they're saying if sine of theta is the square root of 3 over 2, and theta is between 0 and 2 pi. All right, so that second thing, 0 and 2 pi, it just means theta is on the unit circle. All right, if we're on the unit circle and we know sine of theta is the square root of 3 over 2, then what angles could it be? All right, so the first thing you got to look at this is ask what they're asking you to find. All right, they're asking us to find sine. Does sine refer to our x value or our y value? S comes after C, so this is the y value. So what I'm going to do is say, go to the unit circle, find all the points where the y values are the square root of 3 over 2. Well, this one's square root of 3 over 2. This one's square root of 3 over 2. Y value. This one's square root of 3 over 2. Oh, but it's negative. Do I want a negative? No, I don't. This one's square root of 3 over 2. Oh, but it's also negative. Do I want a negative? No, they told me sine was positive. So I'll take this one out. So what two angles could this be? All right, remember cosine, sine is x and y. So there's the first one. What's that angle? In radians. So here's the thing. If they give you, oh, they don't give it to you. Oh, so yes, they give it to you in radians. You see how they say that theta is between 0 and 2 pi? All right, so if you put 60 degrees on this, we're marking it wrong. All right, so they want that in radians because you can see 2 pi is a radian. All right, does that make sense? So the answer is pi over 3. It's also this other angle over here. Here's another positive square root of 3 over 2 for the sine. So it's 2 pi over 3. So those are the two answers, pi over 3 and 2 pi over 3. Those are the two angles where the y value is the positive square root of 3 over 2. Does that make sense? Okay, so today I want you to practice the angles, degrees and radians, okay, and then more practice with just using the unit circle. Tomorrow's lesson will begin with a shortcut to how to remember those coordinates on the outside, and then some more practice. So yesterday was the big one. Every day this week is just about practicing, and getting more familiar with using that unit circle. Okay, if you have any questions, please don't hesitate to reach out to your teachers. Remember, this lesson does come from page 363 to 380 in your textbook. That's always a good resource. Okay, all right, good luck and have a great day.